So I just have introduced the Z transform concept. How do we represent Z transform? X of n. Z transform is represented as X of Z. That means only for discrete signals and also to analyze discrete time systems, DTS systems, we are going for Z transform. Okay, Z transform. So in detail, I discussed about the sequence representation in last class. How do we represent a sequence and the sample index values like this, isn't it? This we already discussed. I mean, using arrow mark that represents n equal to 0. So here all the index values will be positive. This side negative index values will be there. Sequence representation. First of all, you should have the idea how the sequences will be represented. Whether sequence index is starting from 0 or -1, you should have that idea, because then only you can extract the amplitude values from the given input sequence. Okay, so here we are talking about only sequences only, or nothing but discrete signals. Both are same. So Z transform, the standard representation for Z transform is X of n. Z transform X of Z. Okay. Similarly, like in case of Fourier transform, signal multiplied with kernel. Again, in Laplace transform, signal multiplied with kernel. We are changing the domain, right? In the same manner, we have here also formula is there. But till now, we have seen all the formulas relevant to integration, isn't it? We are talking about sequences, discrete domain. So in continuous domain, integration will be there. In discrete domain, summation will be there. Okay. This is somewhat simple compared to integration, because in case of integration, upper limit substitution, lower limit substitution. Here, expansion of summation will be there. Expansion of series. Like series means here comes the concept of progression. Like a geometric progression will be there. Geometric progression formulas we need here. Sum of infinity terms, sum of n terms in a given geometric progression, like that. Okay. So if X of n is a discrete signal, then the bilateral Z transform or two-sided Z transform is defined as, if X of n is a discrete signal, then the bilateral Z transform, bilateral Z transform or two-sided Z transform, two-sided Z transform is defined as capital X of Z equal to, capital X of Z equal to summation, because discrete signal, right? Summation n equal to minus infinity to plus infinity input sequence X of n kernel, like changing the domain Z power minus n. This is a formula for Z transform. Input sequence X of n will be given to us. We have to find the Z transform in sequence values, index values we have to substitute here. Then X of 0, X of, after expansion, X of 0, X of 1, like that, we have to substitute amplitude values depending on the input sequence. Then we have to find X of Z. Okay. So this is bilateral or two-sided Z transform. Similarly, if it is unilateral Z transform, it means, you can guess, unilateral means only positive side. X of Z is summation n equal to 0 to infinity X of n into Z power minus n. Summation n equal to 0 to infinity X of n, where Z is a complex number here. Okay, this is unilateral, one-sided Z transform, two-sided Z transform. Depending on sequence, if sequence is existing two sides, both positive side, negative side, means we take this. Only one-sided means we take this. So you can remember this standard definition for Z transform. What about Z here? In case of Laplace transform, S is a complex variable, right? They represented it as sigma plus j omega. Similarly, here also write down where Z is a complex number, or you can say function, complex number represented as Z equal to R into small r into e power j omega. Very, very important concept, Z transform. Again, in digital signal processing, one complete chapter is there based on Z transform. Okay. Even in there, while designing the filters, poles representation, realization techniques will be there, designing of the filters, everything will be in discrete domain there. Discrete domain means only one transformation technique will be there, that is Z transform. We are not at all going to deal with the continuous signals in case of digital signal processing subject. Only discrete signal will be there. For discrete signal, Z transform technique is used. Okay. Z equal to R into e power j omega, where Z is a complex number, which is represented as R into e power j omega. And what about R means here? R is nothing but small r, radius of a circle in Z plane. So here region of convergence is represented using radius of a circle. Okay. So this is also going to be a complex number because e power j omega is there. E power j omega means e power j theta is cos theta plus j sin theta. So e power j omega means cos omega plus j sin omega. This is also a complex number, but in Z plane, this is represented as, hope you have copied this unilateral Z transform. I am erasing it. So in Z plane, circle, like this, a circle will be represented. And what is the R means here? That is nothing but radius of this circle. This is a Z plane representation. Z plane. Same as this here, real part of Z, and on y-axis, imaginary part of Z will be there. This R into e power j omega in that form. This is a standard Z plane. A radius circle will be there with the radius R. Whatever term is there, that is a radius R. E power j omega, real part on x-axis, imaginary part on y-axis. Z plane representation. Okay. Hope you have copied this. Z plane also you copy. R represents radius of a circle. So Z plane representation we have completed. Just Z plane and definition. Okay. So what is the Z transform technique formula? I said Z transform of x of n. How do we represent? Capital X of Z. And what is the formula we have? N equal to, if it is 2, bilateral means minus infinity to infinity, x of n into Z power minus n. This is a formula we have. But what I said, what is Z? R into e power j omega. While designing the filter in detail, you are going to deal with circle analysis, radius and all. So as of now, whatever required content is there, that only I am focusing in the lecture. Okay. X of n. Now in place of Z, see, I am going to substitute this. R power minus n e power minus j omega n. E power minus j omega n. Just I have substituted this is Z value here. R into e power j omega whole power minus n means R power minus n into e power minus j omega n. So here also same, to define ROC I am grouping the terms. Minus infinity to infinity x of n into R power minus n, because omega is a frequency variable here. I am separating it. E power minus j omega n. So here, after writing this, write down that statement. For the existence of Z transform, here also we are going to talk about ROC now. For the existence of Z transform, so this summation should be convergent. The summation, that means this total thing must be a finite quantity. Finite quantity. Okay. So we have omega is a frequency variable, right? It may be varying from minus infinity plus infinity. So our restriction is only based on this. Even in case of S domain also, Do you all remember magnitude of x of t into e power minus sigma t? We were focusing only on sigma, not e power minus j omega t. Okay. If this is finite, then based on that, we have derived condition ROC. So in the same manner, here also, ROC is defined for the existence of Z transform. The condition here is that for the existence of Z transform, the above summation, continue, write down this, the above summation should be convergent, isn't it? Convergent means finite quantity. So the condition is summation. We are not going to verify this condition while solving the problems. For what values of R or for what values of N, like that we are going to analyze it. For what ranges this summation is going to be convergent. You will get idea while solving the problems. This must be less than infinity. So like this, just this is explanation how when the function is going to be convergent, when the Z transform will be existing. If 2 marks question comes means like this, Z equal to R into e power j omega, we have to substitute, expand it. So this must be less than infinity first of all. After that, we can restrict omega less than 1, like that we can restrict region of convergence. Okay. First of all, this must be less than infinity. That is a condition we have written. Should be convergent. The condition is that this must be less than infinity. Copied this. Next, continuation. So in the same manner, let us write that formula once again, as I'm not having here. N equal to minus infinity to infinity. What we have? What was our last step? X of n into r power minus n into e power minus j omega n. Now I'm taking a special case. If r equal to 1, r equal to 1 means unit circle, radius equal to 1 I am taking. R equal to 1 means that is exactly on unit circle. Exactly on unit circle. The Z transform is defined as, that means substitute R equal to 1. Z transform is defined as, what is x of z? N equal to minus infinity to infinity, x of n. R equal to 1, 1 power minus n, 1 power anything is 1 only, e power minus j omega n. And what is z? We have actually r into e power j omega. What about r? I have taken 1. So this is nothing but capital X of e power j omega. In general, this is written as discrete time Fourier transform of x of n. Discrete time Fourier transform of x of n. You have properties and also problems based on this DTFT in digital signal processing subject. But here, this is our special case. That's it. Just explanation is there. DTFT is introduced. That's it. So DTFT is a special case. It's a part of Z transform here. That is, if you find Z transform exactly on unit circle, it is nothing but discrete Fourier transform. Similarly, do you all remember in case of Laplace transform, exactly on imaginary axis, if you find Laplace transform, that is nothing but Fourier transform. That is x of t into e power minus j omega t. Now compare this with this. In place of t, we have n. In place of t, here also n is there. X of n into e power minus j omega n. Instead of integration, we have summation. Here t was varying from minus infinity to infinity. Here n is varying from minus infinity to infinity. So this is a formula for x of omega, continuous Fourier transform. Whatever problems, whatever topic we discussed in second chapter related to Fourier transform, that is continuous Fourier transform. Then what is the difference between these two means? Here x of t is a continuous signal. And whatever Fourier transform is there, that is also in continuous form. Fourier spectrums were also continuous like this, isn't it? Like that, continuous spectrums were there. Now here, in case of discrete time Fourier transform, x of n, here the name itself is suggesting Signal is discrete signal, discrete in time domain, discrete time signal. Whereas x of this omega is a continuous output spectrum, continuous, not a discrete spectrum. Discrete time Fourier transform. Clear this? So here continuous Fourier transform, input is continuous, output is also continuous. Fourier transform signal is also continuous. In case of discrete time Fourier transform, your input is discrete time signal, but output is continuous domain, continuous spectrum will be there. This is a basic difference. Still anybody wants me to repeat any point? First of all, understood this? Important, this basic difference. Listen here now. Continuous Fourier transform, whatever we discussed first, that is x of t, Fourier transform, x of omega. So this is continuous signal, this is continuous signal, spectrum, continuous spectrum. Next comes DTFT, discrete time Fourier transform. In third year, again same property, same story will be there. What is this? How do we represent discrete time Fourier transform? Means discrete time Fourier transform of x of n is x of omega. Actually e power j omega, but it is a function of omega only. That for that reason this is represented as omega. This one. Okay. So here x of n is discrete, but here it is continuous. After DTFT, again you are going to study discrete Fourier transform. Here x of n DFT, discrete Fourier transform, x of k. So clearly I am mentioning the difference. Here this is continuous signal, spectrum is also continuous. Here it is discrete signal, spectrum is continuous. Here this is discrete signal input, spectrum is also going to be continuous. This is k, discrete frequency variable is k here. X of n, discrete Fourier transform is represented as x of k. K is a frequency variable used in discrete domain. Omega is used in continuous domain. Clear this? Continuous, continuous, discrete, continuous, discrete, discrete. So like this, these two concepts, DTFT, DFT will be there in digital signal processing. Properties, problems are also there in detail, and complete chapter is there based on DFT. And DTFT is a part of Z transform chapter only there. This is a basic difference. Hope you have understood this. Analyzing the content, please copy this. So DTFT is a special case of Z transform. Whenever we are finding Z transform on unit circle, that is nothing but discrete time Fourier transform. Just write that statement. And this is a formula for discrete time Fourier transform. This total thing. This total. Okay. X of e power j omega, x of z. It is a function of omega. Simply, sometimes it is written as x of omega only. X of n into e power minus j omega. Okay. You can compare these two relations. I'm clearing the content. Please write note. Important. Note. Quickly write. When Z transform is computed, exactly on unit circle, when Z transform is computed exactly on unit circle, when Z transform is computed exactly on unit circle, when Z transform is computed exactly on unit circle, it is known as discrete time Fourier transform. It is known as discrete time Fourier transform. Exactly on unit circle, it is known as discrete time Fourier transform. Okay. So next important topic, region of convergence. Region of convergence. So region of convergence, because in case of Fourier transform, for few problems we couldn't solve it, right? I mean, we could not find the Fourier transform pair, because like that we have overcome the disadvantage in Laplace transform by taking particular region of convergence. In a particular side, in a particular region, finite region is there, connected region is there Laplace transform is existing. Beyond that region, there was no existence of Laplace transform. That is region of convergence. Similarly, for any given sequence, for any given discrete signal, the Z transform may or may not be convergent. Whatever formula we discussed, that may or may not be convergent. So hence, here comes the definition of region of convergence. Write down the range of values of Z. Please write, everyone. The range of values of Z. The range of values of Z or set of points. Set of points in Z plane. Set of points in Z plane for which x of Z converges, means finite quantity. Converges is called the ROC, region of convergence of x of Z. For what values of Z, the set of points, range of values of Z or set of points in Z plane, for which that summation formula x of n into Z power minus n is convergent, is finite, is known as region of convergence. That is the definition of ROC. Suppose if there is no value of Z, if there is no value of Z for which x of Z converges, if there is no value, such a region is not there, then we can say that the sequence is not having any Z transform. Then the sequence, how do we represent sequence? X of n. Then the sequence x of n is said to be having no Z transform. Is said to be having no Z transform. Okay. Next, the generalized representation. How do we represent a Z transform function? Means, write down the generalized representation of Z transform is definitely numerator will be there, denominator will be there, isn't it, in terms of Z? The generalized representation of Z transform is given as, how do we represent? Means, see here, this is a standard representation. Some coefficients may or may not be there. They may be 0 also. B0, some constant B1 into inverse powers are used generally for Z function. B2 into Z power minus 2 plus so on. Numerator B1, B2 may be 0 also. Infinity number of terms may or may also be there. 1 plus denominator must be a finite quantity. So 1 plus A1 into, if denominator is 0 means infinity. That's why constant 1 is represented here. Plus A2 into Z power minus 2 plus so on. Can anybody write it in a shorthand representation? Shorthand form using summation symbol. See here how I'm writing. I'm using shorthand notation. Generalized BK suffix K I'm using. Z power minus K I'm writing. And what are the values I have to take? K equal to 0 to n you can take. If n number of terms are there, then n you can take. Okay. K equal to 0 to n. If infinity terms are there means infinity we will write. Let us say only n number of terms are there. Then Z power minus n. This is a shorthand representation of numerator. Then what about denominator? 1 plus summation K equal to 1 to n Here also suppose n number of terms may be there, an into z power minus n. Then how do we represent ak into z power minus k? So this is our numerator in z domain and this is our denominator in z domain. Roots of numerator are known as, same story here also again poles, sorry, roots of numerator are known as zeros, isn't it? Zeros, and roots of denominator are known as poles. Poles are represented using cross mark, zeros are represented using circle in Z plane. So here please write that statement, roots of numerator. How do we find roots of numerator? By equating n of z to 0, isn't it? So roots of numerator are known as zeros. Similarly, roots of denominator, how do we find? By equating denominator to 0. Roots of denominator are known as poles. Copied this. Shall I go for next concept? Do you want me to repeat any point? Okay. Put the heading, next one. Then what are the advantages? As already we discussed advantages and all, why we are studying, because already Fourier transform was there, again Fourier series was there, Laplace transform we studied. Still, why this Z transforming? Definitely some advantages will be there. Again, some disadvantage will be there. To overcome the disadvantage, again some more advanced transformation technique will be there, isn't it? So write down advantages, important. This was also repeated in short answer questions, like 4 marks question, not even short answer, like 2 to 3 questions. Advantages, which includes applications also. Advantages of Z transform. Write down first point. So here also the main application, main advantage is that it converts difference equation, whatever differential equations are there in time domain, we call them here as difference equations. Okay, difference equations of a DTS, discrete time system, into linear algebraic equations. So hence the analysis becomes easy, right? Isn't it? Write that point also. Hence the analysis. So next class we can start problems, because already the formula has been introduced. Everything theoretical concept is over with this class. Analysis becomes easy and simple. Next, one more point, like in case of Laplace transform and Fourier transform, here also Z transform also having properties. Convolution in discrete domain. Convolution in discrete domain gives convolution in discrete time domain is converted into, can anybody guess? Is converted into same statement. Multiplication in Z domain here. So easily we can find system function, inverse Z transform using this. Mainly discrete time system analysis is simple compared to all these statements, whatever we are writing. Next step. Z transform exists for, this is applicable in digital signal processing because we are not having the problems related to this third point. Exists for most of the signals, discrete signals. Don't forget that point, because complete Z transform is only for discrete signals. Z transform exists for most of the discrete signals which are not having discrete time Fourier transform. In continuous time domain signals, if they are not having Fourier transform, means we are using Laplace transform. Similarly, for discrete signals, if DTFT is not there, Z transform, there is a chance of existence of Z transform. Okay, like that. Like that, Fourier transform is related to Laplace transform. Similarly, DTFT is related to Z transform. DTFT problems, nothing is there in our syllabus, only Z transform problems concept is there. Okay. Limitation, can anybody guess the limitation? Same as Laplace transform, exact frequency response we cannot plot. Frequency spectrum. Okay, add on that one. Frequency, main thing is stability, solving the differential equation. These are the applications, system related applications are there. Frequency domain, response, power spectrum, energy spectrum, response cannot be plotted, cannot be achieved and plotted. Only this is a limitation. So after that, problems will start in next class using that summation. So all of you please refer geometric progression formulas now. So integration formulas we don't need in Z transform concept. Again in 5th unit, the correlation, while solving correlation we need integration formulas. Whereas for Z transform problems we need series related formulas, infinity series, sum of n terms, like that. Geometric progression, arithmetic progression formulas we need here in solving the problems. Okay. So for next class, all of you try to solve this. So let us start with the standard basic formula. Basic signal, discrete signal. Find out the Z transform for the unit impulse sequence. There every time we used to write signal. Here sequences, unit step sequence, exponential sequence, causal sequence, anti-causal sequence, all sequences, nothing but discrete time signals. Okay, try to solve this. So next class we'll continue this. Okay, if you have any doubts you can ask.